again to another episode of the Regenerage show, the premier show for everything along the topics of human health, aging, regeneration, repair, and rejuvenation. I'm Ira Pastor, your host. Today's episode is entitled, What Causes Biologic Aging? So, on the last show, we discussed the topics of what biologic age and biologic aging are, and the fact that biologic aging represents changes to four key parameters: your fitness, fertility, robustness, and resilience over time, and that these changes are integral to either supporting your health and wellness throughout life or promoting your subsequent descent into disease and degeneration. We also discussed that paradoxically, how for a decent portion of your life, even though you are technically aging chronologically, your fitness, fertility, robustness, and resilience are all going up, demonstrating the biologic separation that exists between aging at different stages of life and the onset of the diseases of aging, and there are powerful natural endogenous control mechanisms behind the directionality of these processes. On this show, we're going to go into the core drivers behind the scenes of these bidirectional changes in biologic aging. Now, over the past couple of decades, as the study of aging and longevity as areas of biotherapeutic interventions have become more popular, an extensive catalog has grown and continues to grow, with everyone's key aging hallmark or damage target of interest piling into the mix. This lengthy list includes, but is by no means limited to, the following: inflammation, oxidation, heat shock, microbial burden, xenotoxin accumulation, somatic mutations to the genome, epigenetic modification, stem cell exhaustion, senescent cell accumulation, damaged mitochondria, telomere variability, extracellular matrix cross-linking, nutrient sensing dysfunction, intra and extracellular aggregates or junk formation and accumulation, and on and on and on. And while this list no doubt contains a wide variety of fascinating topics connected to health and aging, and areas for potential pharmacotherapeutic intervention that may improve the outcomes in various disease states associated with aging, none of what I have just listed has anything to do with the underlying driver of aging. Let me repeat that. None of what I have just listed has anything to do with the underlying driver of aging. How do we know this? We know this via a very simple fact that unfortunately gets swept under the rug as it challenges the ingrained doctrine in longevity biomedical research. And that is this: all of these aging hallmarks or forms of damage that I've just listed are not only found in elderly, decrepit, disease-ridden individuals, but also happen to be found, some to a much greater degree proportionately, in the earliest stages of life in developing embryos and fetuses. Take time to think about that one for a moment. All of these pathophysiological outputs that are present during our descent into disease and degeneration in later life are paradoxically present at the very beginning of life, when we are becoming more fit, more fertile, more robust, and more resilient. Let's take a look at a few examples of this, of which there are many others, in a bit more detail to really fully appreciate what's going on. The fetal brain, as an example, contains a wide number of amyloid and biochemical similarities to the pathological Alzheimer's disease and Parkinson's disease brain, namely the presence of beta amyloid precursor proteins, hyperphosphorylated tau, presenilin 1, alpha-synuclein, all of which are integral in the development of more neurons, as well as the formation of proper brain structure as we develop. Another example: the majority of all somatic gene mutations, the main focus of the cancer oncology research system for the last half a century, that is based on the somatic mutation theory of cancer. that you experience throughout a lifetime, manifesting across the trillions of cells that make up your body, occur during the first 9 months of life when you are still in the womb, due to all the cell division that's occurring, not after your birth, during the majority of your lifetime, where cancer incidence typically rises substantially. One more example. Your body at the beginning of life is chock full of senescent cells, or non-dividing zombie cells as they're referred to, which are found present in every diseased tissue in the body in later life. However, which at the very beginning of life are extremely important for your body's patterning. You wouldn't form without them, not to mention for your wound healing and cancer prevention. This is truly amazing. All of the things that are connected to killing us later on in life, present at the very beginning of life, during a period where we're becoming more fit, more fertile, more robust, and more resilient. What does all this mean? What it means is that there is a higher level set of control processes in the biological architecture of your life, which are in essence, calling the proverbial shots as to why and when we age, which all of these so-called hallmarks of aging and forms of damage are subordinate to, and which, when these processes go awry, lead to our descent into disease, degeneration, and death. And those integrated control processes are the ones that are responsible for constructing, regulating, and maintaining your biologic form. Biologic form control systems represent the true master control centers of biologic aging processes in humans. And this is not about a certain gene or a certain protein or a stem cell. It is about complex nested hierarchies of bidirectional combinatorial interactions at all levels of your body, from your DNA, cells, tissues, organs, limb and body segments, that work together to keep you whole and functional during a lifetime, and they're both biochemical and biophysical in nature. So in our next episode, we're going to go a little deeper into this theme of biologic form control. We're going to take a look at a range of species that tap into these control mechanisms throughout their lifetime for reversion of disease, for stimulation of regeneration, and for the reversal of biologic aging. And we'll begin to talk about how we can leverage some of these clues for the benefits of human beings, as interfering with these dynamics is going to take a little more complex thinking than your traditional sort of single magic bullet model that the pharmaceutical industry has followed for the last 100 years. Also, we're going to talk a little bit about how everyone's that's interested in anti-aging longevity research, said stop thinking about your body as a classic car that can be fixed as such. Throw this ridiculous analogy out the window, and we'll show you why. Now, moving on to the non-mandatory homework part of the show. The paper that we're going to be suggesting today on the show is entitled Remembering the Body: Applications of Computational Neuroscience to the Top-Down Control of Regeneration of Limbs and Other Complex Organs by Michael Levin's group at Tufts University. And once again, you can access all these papers on National Institutes of Health PubMed database. And this is really a fascinating paper as we continue to explore the themes of these natural endogenous form-regulating mechanisms that humans and other organisms have, and really gives a fascinating overview with what we'll call a top-down control perspective on human aging. So once again, thank you very much for joining me again today. Once again, I'm Ira Pastor, your host of the Regenerage Show. If you like what you hear on this show, please encourage you to subscribe to this channel, as well as following us on all forms of social media, including Facebook, Instagram, LinkedIn, Twitter, and other social media. Once again, thank you very much for joining us today. Best wishes in health and a long life.